Just real quick, brief intro about myself. Again, my name's Alex Taguchi. I'm the lead technology architect here at Hawk Ridge Systems. I've been here for 13 years, and for most of my career, actually, I was in technical support. And so I've worked with thousands of you over the years. And one of my passion projects and specialized topics was hardware. How do I get the most out of SOLIDWORKS performance out of the computer that I was given, so that way I can do my job faster. If it's either working with a customer on their designs, or if it's just getting tasks done with my own job. What components of a computer do I need to know about, and what functions in SOLIDWORKS could potentially be bottlenecked by certain components in that machine. I've also dabbled quite a bit with virtual desktop infrastructures, and so hardware and performance is really it's really an important subject to me. So let's get started. Again, I've got Stephanie Rodas, who's the application engineer on the video with me as well, and she'll be taking over about halfway through the presentation. So what we're going to start off with are the basics. I just want to make sure that everyone here has a similar foundational understanding of the four major components that make up your computer, and also that determine your overall performance for SOLIDWORKS. So really, the first, I'm going to start in importance, and the most important thing is really the processor, or the central processing unit. This is going to determine overall the performance that you're going to get in SOLIDWORKS out of your computer. It's the most important decision making that you can make typically when you're speccing out your next computer build. And so there are three main components of a processor that will determine its performance. There's the clock speed, the speed at which one core can operate. So you'll see that noted by a clock speed, and you'll see it usually a base speed, and then you'll see a turbo boost speed, which is its maximum performance. And you'll see a core number. Typically, you're going to see 4, 6, 8, 10, 12 cores now. And that's just how many simultaneous threads it can process at any given time. And then the last number, or last metric that I want to talk about that really people don't talk about all that much, is instructions per clock. And you're not going to see that listed as a specification on any spec sheet or anything like that, but the easiest way to understand that is for every given hertz or clocks of your processor, it has a certain amount of instructions that it can handle in that given hertz, and that's going to determine how efficient or how fast your processor is over the years. So that's why it's really difficult to take a processor from today, that's 4 gigahertz, let's say, for example, and compare its performance to a similar 4 gigahertz processor from 4 or 5 years ago. It might look similar, you might have similar cores, you might have similar clock speed. However, the instructions per clock typically increases by about 10 to 15% every generation of processor that comes out. So it might be significantly faster or complete the same task in a much shorter period of time on the newer processor versus the older processor. The only way that you can really gain instructions per clock or take advantage of that is simply by increasing your or just purchasing a new computer that has a newer generation processor. So that's why you'll see like the Intel 9th gen or 10th gen or 11th gen or the upcoming 12th gen processors. Each one of those generational improvements, they do make improvements to that instructions per clock. And by and large, in SOLIDWORKS, most of what you're seeing is going to be single-threaded. So every time you're working on your part, adding features, editing features, working on large sketches, adding mates, switching back to your drawings, waiting for it to rebuild, and you're seeing that blue circle spinning. All of those tasks are all single-threaded tasks. And so having more cores doesn't necessarily improve performance in those scenarios. So when we're talking about processors, typically you want to think about clock speed. So the second thing that I want to mention is the GPU, or the graphics processing unit, or the video card. That's what's responsible for displaying all the nice 2D and 3D graphics on your screen in SOLIDWORKS. I'm not going to talk about really the chipsets and cores and RAM, because it really doesn't matter all that much. But really, the only reason why you'd want to spend a little bit more on your graphics card is if you are working with large assemblies where your triangle count, your vertex point count is really high, or you're working with a lot of silhouette edges, things like that. you can start to bog the process or the graphics card down because it's going to be determining your panning, your zooming, and your rotational speeds of your camera viewpoint. So if you are noticing with your larger files that you're working on right now that your pan, zoom, rotate is a little laggy or it's not very smooth, then maybe the next time you look to purchase a new computer, you might want to spend a little bit higher, a little more on your graphics card. But for most people, entry to mid-range is going to be plenty. The third component that we want to talk about is the RAM. Random access memory. This is temporary storage that gets loaded from your storage drive, your SSD, into RAM that's hyper fast, low latency that your processor can access and process information. So RAM is the faster temporary storage. However, it's temporary, and it really is only going to impact performance when you reach your max capacity of RAM and you start paging. So RAM, in terms of performance, you just need to have as much as you need, and it's one of the cheapest components, least expensive components of your build. So just double up of however much you think that you're going to need. So as long as you've got enough and you're not paging that too much, which is essentially going to happen at 80% of your when you reach 80% of your RAM capacity, then if you look at your task manager and you see RAM and it says 80% consumed, it's time that you should probably either upgrade RAM or your next build should have double the amount of RAM that you currently have right now, because your system is now paging and that can slow overall performance down. And then the fourth component is the SSD, or the storage. This is your static storage, your permanent storage drive. And the most important acronym that you could see when picking out a computer is that NVMe label. That just stands for it's the fastest technology storage that you can get right now. If you want to get nitty-gritty with storage drives, there are different classes or generations of NVMe drives. And so the 4th gen, which is brand new, is just coming out in the last year, is by far the fastest. However, the reason why I list this last is because it really is impacting very little when working with SOLIDWORKS, other than opening files and saving files back to your drive. That's really the only time that you're going to see the performance of an SSD at play within SOLIDWORKS. A couple exceptions to that might be if you're working with simulation and you have very, very large results files, in the hundreds of gigabytes in size. Those are essentially just raw text files that it's writing to your disk, and it writes them very, very, very fast. So yes, you can see the results file like in that scenario. The SSD actually could cause a performance issue with your overall simulation results time. But for the most part, it doesn't really matter too much in terms of overall performance, except for open and saving, of course. I just want to touch on one real quick here, is that, and why is SOLIDWORKS mostly single-threaded? Wouldn't it be better to be multi-threaded? Absolutely. Over the years, I'll just touch on this real quick, SOLIDWORKS has added multiple solvers behind the scenes or have improved on the solvers so that certain tasks can be multi-threaded. It's not that everything is single-threaded. It's just that the nature of a parametric modeler, where you have to have a sketch before a feature, right? And then another feature has to then add on to that. You've got a linear process of things that need to be calculated before the next thing gets calculated. Means that most of the time you're just waiting for a single processor to be able to process all those things in a linear fashion. So it's the way that it's going to be, and I anticipate them taking advantage of multiple cores in certain scenarios, like opening drawings in multiple sheets. They already do that. That's multi-threaded. And so where they can, they will take advantage of them. And every year they add new improvements, especially on the simulation and flow sim, which Stephanie will talk about later. I'm going to be talking about the base speeds and turbo speeds in a little bit in the next slide here. So the next slide I want to talk about is, when do I upgrade? So for benchmarking and monitoring, I'm just going to talk about a couple tools that everyone has or can go get really easily, and take a look at your system and analyze it to see, okay, do I already have a pretty good system, or should I have gone a little bit more on processor or RAM or whatever it might be, so that way you can make an informed decision next time, or maybe upgrade your current machine. So there's the SOLIDWORKS RX tool. And the RX is built into every SOLIDWORKS install. So if you just go into your start menu at the bottom, type in RX, it'll bring up the RX utility. If you've ever worked with tech support, we always ask you for an RX benchmark, so you're probably familiar with it. But if you open up the RX tool, not only is it good for troubleshooting issues, if you go to the very far right tab of the RX, there's a benchmark tab. You click on that and you hit start, and it'll test your processor, your IO, your storage, your graphics card, all those components that I talked about, and it'll do a bunch of tests. Like it'll open up SOLIDWORKS, rebuild a file, rotate its pan zoom, rotate, close it, open up another file, and do that over and over again. And it's just measuring time, how fast your computer can complete all these tasks, and then the lower the time, the better. It's a pretty short benchmark. It takes about 15, 20 minutes or so to complete this. And just one asterisk I want to add about the RX benchmark. It is version specific. So you can't test like a SOLIDWORKS RX 2021 versus a SOLIDWORKS RX 2020 and compare the results, because they make changes from year to year. It doesn't work that way. So you'd have to make sure you test on equal years if you're going to use that utility. But what you can also do is when you're done, you can click Share My Score. It takes you to the SOLIDWORKS public benchmark site where you can compare your results versus the communities. You can see processors, you can see RAM, you can see what graphics card that everyone's using, and you can see what the resulting score is. So you can get a good idea of how your machine stacks up against what everyone else is using. Of course, we've got the task manager. Here's the RX. I've got the screenshots. I'm a little bit behind here. The task manager is a fantastic tool. We use it all the time in tech support. This is a screenshot from my machine right before I got an upgrade last month. And it's showing that the main components that I just talked about, you've got your processor tab showing I'm at 25% utilization. I've got my memory, my RAM, which is at about 66% utilization. You've got my SSD showing at 1%, so no utilization there. And I've got my two graphics cards on my laptop. So I have the Intel card and I had an NVIDIA Quadro on my system at the time, and you could see that it's using almost 0% of those. So in this screenshot, I could see, my RAM isn't at capacity, but I'm getting there at 66%. So maybe 16 gigs of RAM might not be enough for my machine the next time I open up a large assembly or something. And then as far as my processor goes, it was pegged at that time. And so what I was doing actually is I was opening up about a 500 part feature, and I just did a control Q. And it was just sitting there with the blue circle spinning, and I was waiting for it to finish a rebuild. And it was pegging essentially one core or two cores to complete that rebuild process. And that's why it's showing at about 25% utilization. And the other things that I'd recommend, there's a website that we use to correlate our own testing, and that's Puget Systems. They're a hardware vendor. They do fantastic custom benchmarking that test the same things. They actually built their own to test flow, sim, large assembly performance, drawings, a lot of different things. That it's a much more advanced test than what the RX benchmark does. And so if you're really curious about the latest and greatest processors that come out from Intel or from AMD or the graphics cards, Puget Systems puts out some of the best blogs. So take a look at their website. I highly recommend it. And then for those of you nerds out there who really want to test, at that level on your own system, there is a utility out there called SpecView Perf, and it is the industry standard for hardware benchmarking, especially for CAD applications. They have one built for SOLIDWORKS. So you just need to have SOLIDWORKS installed, you download the utility, and it'll run your system through, I think it's like a 2-hour run benchmark, but it'll give you so much detailed information about how your computer is running and how it compares to other computers out there. So I just wanted to throw a poll out there real quick before I talk about, before I move on. There's also a timing element. When do I upgrade, right? What's the right time to do it? Is it a certain time? Is it based on technology? Is it based on my company? So just real quick, I'm going to launch this poll. I'm just wondering, how often does everyone here upgrade your computer or replace your computer? Poll's open now. Let's just click over there to the right next to the chat, and then you should be able to see it. All right. Cool. So it looks like, yeah, okay. By far, the majority of you are upgrading between 3 and 5 years. That's pretty good. You know, got a small percentage of you guys upgrading 1 to 3. Lucky you. And then another smaller percentage upgrading 5 years or more. Okay, so let's talk about that real quick. Thanks for your participation there. So the way that Hawkridge Systems makes our purchasing decisions for our own engineers, we're buying, a couple dozen high-end workstations a year from our vendor, and we've got quite a big staff here. How often are we buying computers? Well, we are buying machines roughly, or replacing them for our engineers, roughly about every 3 years. And we don't typically buy super high end. We're not spending $5,000 a machine. We're spending usually about $2,500 a machine on laptop machines for our tech support and our application engineers. We do have some other higher end machine builds that we do buy for some of our simulation and Abacus users, but for the most part, that's about what we're spending. And we have found that rather than spending super high end and expecting it to perform at a high level 5-6 years from now is unrealistic. The technology simply gets eclipsed, every 3 to 4 years. And so in order for us to stay on trend with the latest IPC, the latest processor, latest technology, and also we're always using the latest and greatest version of SolidWorks. I've already got 2022 installed on my machine. In order to take advantage of some of the new features and new technology features that keeps getting added, it requires that we be on pretty recent hardware. And so we found that return on investment of a $5,000 machine over the course of the 5 years just quite isn't there versus spending $2,500 every 3 years. We find that we're getting much better performance overall by taking that life cycle approach and rather than the other approach. And we're hardly ever upgrading them. We typically just buy them with what we need at the time, with the exception of RAM. Sometimes we'll upgrade the RAM later on down the road, but most of the time we buy it, we run it for 3 years, and then we replace it at that point. So just wanted to touch on that as far as our own purchasing and life cycle. So just want to talk about some specifications. So here we're going to talk about actual CPU models, GPU models, and stuff like that. But before I do that, I really want to touch on these terms that you typically hear out there, and that is, what's a recommended system versus a certified system versus a tested system versus something that might be ISV. Well, you're going to see a lot of those, especially if you take a look at your hardware vendor. If you go to Dell's website or Lenovo's website, et cetera, you're going to see a lot of these terminologies thrown around. ISV just stands for independent software validation, and that means that hardware manufacturer provides their computer to different software vendors like Dassault Systems for validation. And SolidWorks has their own hardware certification site. If you just Google it, SolidWorks hardware certification, you'll take you right to their page, and they will show you a database of all of the machines that they put through their own hardware validation. So that means they get every laptop, every desktop, every graphics card, every processor, like all of it. They have a lab and they put it through a battery of tests. They load it, they put the latest version of SolidWorks, they'll put a specific video card driver on it, put it through battery tests, and then they'll get the green check mark, or it doesn't. If it doesn't, it just doesn't end up on the database. So if it passes and it's on the database, that's a good sign. So if you're looking for a quick list of machines that have certified, that means that it has passed SolidWorks' tests. What we recommend is usually going to be minimum requirements plus. So number one, every single thing that you see here would be on that hardware certification list. But also, we don't typically recommend the minimum. We want to get the better performance for the best value. So that's what we're going to talk about. So what's the build? It's Windows 10 64-bit. Just a note there, I've added Windows 11. Windows 11 is out. It launched last week, or on October 5th, so almost 2 weeks ago now. It is not supported. Do not install it. SolidWorks, we've already seen some people try it. It does not go well. So Windows 11 support is not yet announced, and we don't anticipate it until mid-2022. So that means that the first version to gain support for Windows 11 likely will be a mid-service pack version of 2022. So we don't know quite exactly when that's going to be, but anyone who's currently using SOLIDWORKS 2021 or older, you need to be on Windows 10 64-bit. So what are we going to talk about first? What processor to use? It's the most important component. As I mentioned earlier, clock speed is king when you're picking out a processor. So that's what I've got listed here. I've got high-end desktop, mid-range desktop. I've got high-end laptop and mid-range laptop as well listed there. I've got two tables, a blue and a red one. The blue one is Intel. That's just because if you go to any major hardware vendor, almost every single workstation class machine that you will specify and buy will have an Intel-based platform. You are starting to see a few vendors. Lenovo was kind of the first to take that step into the AMD processor range. So I felt that it was fair to mention them here because we are starting to see them offer a compelling offering right now. And so just real quick, I want to talk about some of those CPUs listed there. So we've got the i9-11900K as the tippy top highest end processor that you can get for desktop processors right now because again, I don't have the clock speeds listed here, but I think the base speed is 4 gigahertz and then the turbo boost is 5.3 gigahertz. It's a screamer. It's super fast. It's really an amazing CPU. And then the 10900K is just the previous generation. So you're going to see some processor or some towers still offering the 10th gen CPUs, but you're going to start seeing more and more with the 11th gen. That's the 11900. That's the 11 numbers, the generation. So that's how you can see that. And then mid-range, it's just you go down a little bit, 11700K, 10700K. And then there are even some entry level below that are still totally fine for SOLIDWORKS. But again, you're going to have fewer cores and lower clock speed as you go down the chain. And then as far as laptops, we've got i9-11950H, and we've got the i7-11800H, the laptop that I'm running right now. It is a Lenovo P1G4. I just received it about a month ago, and it has the i7-11800H, and it's awesome. On the AMD side, they don't make laptop CPUs in any workstation class, so it's not worth mentioning. But as far as their desktops go, they do have Ryzen 9s and Ryzen 7s and Ryzen 5s. It's kind of similar to the i3, i5, i9 nomenclature. Excuse me. The only kind of main thing I want to mention in terms of the AMD processors here is like, why would I go AMD? Why would I go Intel? Is you're going to get high clock speeds and more cores on AMD. Now, if you want the absolute fastest clock speed, Intel is still king. You know, the 5.3 turbo boost speeds, AMDs aren't quite getting up that high right now. I think the 5950X max turbo speed, I think is 4.8 or something like that. So still pretty fast, still pretty high, and you do get more cores with the Ryzens, but their clock speeds aren't quite. So for single-threaded, raw single-threaded application performance, we're seeing that Intels are still are edging it out a little bit. But yeah, they're totally valid choices for a computer build for SolidWorks, either Intel or AMD. So I do want to add one note there as far as Xeons. The Xeon CPUs, I don't specifically list them here. It's not that they aren't compatible, and it's not that they aren't good processors. It's just that the only benefit that Xeons grant your platform is the ability to go to ECC RAM. If you buy a machine with an Intel Core or whatever, that means you're running non-ECC RAM because those motherboards don't support it and those processors don't support it. Well, what that means is that the ECC RAM is made for maximum stability. They can self-correct essentially failures when it's writing ones and zeros. So if I've heard anecdotally that machines with Xeons and ECC RAM are stabler than machines without it. I haven't seen a single white paper that proves that or disproves that, so I don't know how much validity there is to those statements. But if you're concerned about that in any way, like I heard someone say, we typically run 12-hour-long simulation runs or 24 long simulation runs, and we can't afford a crash okay, maybe it's worth considering going Xeon platform for ECC RAM. But as far as like raw processor performance, no, there isn't a single Xeon that offers higher clock speed than the Core i9s from Intel. So that's why we tend to recommend the Core i9s and i7s as a good place to start. So the next thing we'll talk about is graphics cards. So I'm going to cruise through this real quick because I'm running out of time for Stephanie's part here. We only recommend workstation class. So that means an NVIDIA Quadro or NVIDIA RTX A series graphics card, or on the AMD side, Radeon Pros. If it doesn't say that, that is not a workstation class. It's a consumer or gaming class graphics, and therefore it doesn't go through any validation or testing by Dassault Systems. So performance, stability it's not guaranteed. So the cards that I've got listed here, like the laptop I have, has the NVIDIA Quadro T1200s from that mid-range there, and it's totally fine for what I use it for. If you need to go higher, you can go to the RTX A4000, which is the latest and greatest that just came out. There really isn't a need to go higher than that, unless you're using Visualize. So that's the only asterisk that I want to add in there. We're recommending 32 gigs of RAM for your system. It does list 16 as a minimum, just double. It's a cheap upgrade. 32 is usually plenty for most people. You can go to 64 if you want. And then NVMe SSD, like I mentioned earlier. That's really where you want to be in terms of storage for reading and writing. Okay, so let's move on to the operating system. Couple notes here. We're recommending take a look at the SOLIDWORKS hardware certification site for the latest driver that you should be installed and running for your graphics card. They'll list it. Currently, most of the NVIDIA cards you'll see will have the R460 or R470 graphics driver. So if you're not running that right now and you're on SOLIDWORKS 2020 or 2021 or 2022, you're going to want to upgrade your graphics driver. It can greatly improve performance, but more importantly, it can greatly improve stability. So always use the version that's on the hardware certification site. And the last two notes is automatically manage your system page file. We've seen customers try and manually set their page file to double their RAM. That's a legacy Windows XP 32-bit thing. Everyone should stop doing that. Windows 10 is extremely smart about automatically managing your page file. You don't need to do anything with it anymore. So however your operating system is, if it's been tinkered with by your IT or something like that, you should have a conversation with them to revert the page file to automatically managed, because SOLIDWORKS R&D does not test it with manually paged. They test it with automatic on. So you might be seeing stability issues because you've switched it from the default of your operating system. So set your page file back to the automatic, which is what this screenshot is showing here. And then UAC is a security mechanism. We just recommend leaving it at the default for all installation and performance and stability concerns. So I think that's the last slide that I have, and I'll hand it over to Stephanie.
All right, thank you, Alex. And hello, everyone. My name is Stephanie, and I'm an applications engineer here at Hawkridge Systems. I've been part of the technical support team previously, and I've been with Hawkridge for over 4 years now. So before I do get started here, I do want to take a quick poll here. Let me go ahead and launch that. Just want to check to see what version everyone is currently using. So if you guys can go to the right side and take a look at the polls there. Right, so getting a few answers here. Looks like different versions we have. So what I'm going to talk about here is some ways to improve your performance. And one of the easiest ways to actually improve your SOLIDWORKS performance is by simply upgrading the software. So every year, SOLIDWORKS tries to make the newer version better than the last for some specific scenarios, and we're going to talk about some of those here. Before I do get started, I do want to mention that in order to get these improvements when upgrading, some of them are in the back end, meaning all you have to do is upgrade and use that version. And then some of them you might need to turn on an option or use a specific setting. So starting off with 2020, we saw some significant improvements with PDM background and search query, specifically with the addition of that new quick search functionality. They also introduced the new detailing mode for drawings and the enhanced graphics performance. And both of those actually got a significant improvement in 2021. So in 2021, a lot of what would appear to be graphical calculations and drawings were actually calculated by the CPU. Well, with enhanced graphics performance, a lot of this can now be offloaded to the GPU, so things like panning, rotating, or simply updating your drawing views are now going to be calculated from the CPU, making it faster. We also saw again some more improvements with PDM. A lot of these like file-based operations like check-in or change state, these are going to be faster in 2021, especially for those users that are maybe working remotely or over VPN or WAN environments. And this is actually a theme that we're going to see with PDM in the upcoming years as well. And then for simulation and flow sim, every year or two, they try to take advantage of the updated solvers. So if you have multiple cores, you can start utilizing more of those cores towards the final solves. And then in 2022, so 2022 is going to be set to be released at the end of November. And we're going to see a lot of significant improvements in 2022. So back to that enhanced graphics performance, we're going to see improvements with silhouette edges in parts and assemblies. So a lot of these visible edges that you see when you're like panning, zooming, or rotating, these are now going to be calculated by the GPU, meaning that not only you're going to see the same edges the entire time, but it's going to be faster. And then we're also going to see some improvements with importing files, specifically the importing large step files. I know a lot of users work with step files, and not only is importing going to be much faster, but also saving, which can also take a long time, as some of you may know. And then probably one of my favorites for Pack and Go. Pack and Go is going to be much faster in 2022. So gathering those references is going to be much faster than any other release. And they're going to add a progress bar to Pack and Go so that you're able to see how long it's going to take, which is pretty awesome. And then last but not least, there on my list, I have the PDM again. So that back to that PDM improvements, they're going to try to make PDM much faster for users that are working with high latency environments. So pretty cool things we're going to see there with 2022. And then now moving on to some settings. So as you guys may know, SOLIDWORKS comes with a bunch of settings that are enabled by default. And some of these settings are not enabled or disabled with performance as the priority. So we're going to talk about some settings that we can change in order to have performance as the priority. Before we do that, I do want to talk about what these settings do, because you don't want to just turn things on or off, right, as they can change your workflow. So the first one I'm going to talk about here is going to be the internet connected settings. So these are found in the system options general tab. And what these settings do when you launch SOLIDWORKS, it tries to connect to the SOLIDWORKS site to gather information like news, technical alerts, or updates. And then it puts those in your welcome dialog once it opens SOLIDWORKS. Now what can happen is it could take some time to gather that information. So if you're noticing that maybe it's taking longer to launch SOLIDWORKS, you could just try turning these off. And then another one similar to that is the 3D Content Central search setting. So if you ever search for files or models in the top right search box inside of SOLIDWORKS, well, if you have this setting on, it's going to look through 3D Content Central as well and give you any of those search results. Now, if I'm searching for files and models, typically I want to look locally, so you might just want to try turning this off to save some time. And then we have some update settings. So these right here are specific for drawings. These are under system options, drawings, performance. I want to talk about that allow auto updates when opening drawings. So when you open drawings, this is going to basically, if you have this off, it's going to stop your drawings from automatically updating as you open them, which reduces the time to open them. However, again, these are system options, so they are going to affect all drawings you open. So you might want to just test it out, see if it is a significant improvement. If it's not, you could just try using the new detailing mode for drawings, or you can open your drawings in lightweight. And then similar for updates, we have these update settings for assemblies. And these are not the default settings that it comes with. So the two that are definitely not on by default that I'm going to talk about is the do not rebuild when switching to the assembly. So this setting, if you're in a part and you switch to the assembly, it's going to automatically build time to just open that file back up. And the other setting there at the bottom, which is the suspend automatic rebuilds. So a lot of the time you have things that trigger rebuilds in SOLIDWORKS for the assemblies, and this is going to try to suspend those from happening. Now, just keep in mind that it's still going to let you know if a change has occurred, and if a rebuild is needed, it's still going to give you that rebuild icon. So don't worry, you're not going to miss any information there. And now we have some graphical settings. So these are going to improve performance that are all graphical. At the very bottom there, we have that enhanced graphics performance. By the way, these are under performance system options. So I did talk about that setting a little bit at the beginning. This enhanced graphics performance, it does harness new graphics card technology. So if you're not using a new graphics card, you might not get the benefits of this setting here. So if you are using a newer graphics card, it can make things like panning, rotating, or zooming much faster. And right above that, we have the mate animation speed. So this setting right here, if you ever have gone in an assembly and made it to components, let's say I take two components and make them coincident, you'll see the animation of them becoming coincident. Well, if you turn it off, it's just going to snap them into place. The one caveat to this is if you accidentally select two things and one thing flies off in space, you're not going to see the animation of it flying off in space. So just keep that in mind if you do decide to turn this off, what it's actually doing. And then above that, we have level of detail. So this is the level of detail you're seeing during dynamic view operations. So the thing about this level of detail is that if you have it all the way to the far right, when you're rotating an assembly, you would see the components maybe turn into like simple polygons. And as soon as you stop that rotation, it goes back to high fidelity. Well, we actually found with modern graphics cards, it's actually faster if you just turn this all the way off because it doesn't have to calculate for what the simple geometry would be and then go back. Instead, it just uses high fidelity all the time. And then just some additional settings here. So these are under the heads up toolbar. These are view settings. Typically, I like to just turn off real view graphics, shadows and shaded mode, or ambient occlusion. Again, if you're using modern graphics cards, you might not have a big impact with using these settings. But if you are looking for maximum performance, then you can just turn these off. And then this is one of our favorites here, this image quality setting under document properties. So we see this a lot in technical support. This setting is under document properties, so it's specific to each document. And a lot of the times we see users move this slider all the way to the far right. Now, what this does is it actually doesn't change the geometry, just the edge fidelity. So if you have it all the way to the far right, you might see your edges look smoother or finer. However, it is taking longer for the graphics to rebuild. So if you ever see updating graphics in the bottom left, you might have this off to the far right. And for most users, you actually just can turn this down about a third of the way, should be okay. Of course, if you do want to see things a lot smoother, you can come back here, change it, and then change it back. And now we have some view transition settings. So I like to just go ahead and turn these off. But just to give you an idea of what these do, so the very first one there, view transition, if you ever have switched from a standard view to another, so like top to bottom, you would see that animation of your actual model moving. Well, if you turn it off, it's just going to snap to the next view. Same thing with like hide show components. If you hide something, you may have noticed it goes from like opaque to transparent and then disappears. Well, if you turn it off, it's just going to go ahead and disappear altogether. So that's what these settings there are doing. And then one thing that's not mentioned here that I do want to point out is if you work with transparency, you might want to consider using display states because transparency does add significant overhead to your graphics performance. So for that, we would suggest if you do work with a lot of transparent components, you might want to have a display state where those are switched between your to improve performance. All right, and then some other settings that you might not be too familiar with. We have the lock rotation for toolbox components. This is under Whole Wizard / Toolbox in your system options. And what this setting does is when you use a concentric mate for a toolbox component in an assembly, it automatically locks the rotation. So usually if you add more mates, this is going to add a greater load on your processor or RAM when you're rebuilding. And the nice thing about this setting is it's going to lock the rotation without the need of those additional mates. Now, some other settings here are the auto recovery and the backup settings. So specifically that auto recovery, when you're saving these files that are open, if you have it to save too frequently, you might notice that if you have a bunch of large files open and it's saving, you might get some kind of like stutter or delay. So you might want to consider reducing the frequency at which your files are saving. And then the last settings I'll talk about here for external references, want to mention specifically the one for search external references in. Typically, you do want to have this include subfolders off because if you have it on, it's going to search through your drive and all of the subfolders, making your search take a lot longer when it's looking for those external references. And most of the time, you don't actually need to look through all the subfolders. So that's why we turn that one off. All right, so now we are coming towards the end here of our presentation. So I do want to talk about a few reference materials that we use and just some things that could be useful to you guys. So first off, that solid practices that you see listed there, that solution is for managing large assemblies. I know a lot of users work with large assemblies and often ask improve our performance, what recommendations or settings can we use? And that can be found by logging into My SOLIDWORKS or customer portal and going to the knowledge base. If you search up that solution, there is a PDF that's associated with that that has a lot of recommendations for any users that are looking for more information on managing those types of files. We also have some additional tools there that are available. I know Alex talked a little bit about the RX and the benchmark, so I'll come back to that. We do have the performance evaluation and assembly visualization. So first off, the assembly visualization tool, if you're ever working with large assemblies and you want to see, if what components are affecting your large assembly performance, you can actually go into the assembly visualization tool and it has information about like the open time or the rebuild, how long is maybe one component taking to rebuild could be affecting all your whole performance of the assembly. And you could even filter or sort, sorry, not filter, you can sort by the columns that you see there. And then we do have performance evaluation. So that's kind of similar to assembly visualization. This is giving you information about all the open files that you have in SOLIDWORKS. Not only is it analyzing the files, but it's giving you recommendations. So just as an example, we see this one has like graphics triangles. It tells you might try to simplify your model in order to improve your performance. And then similar to that for parts, there's also performance evaluation. And by the way, these can be found under Tools Evaluate. So in both parts and assemblies under Tools Evaluate. Performance evaluation for parts, this is checking the rebuild of all the features that you have that were used to create the specific part. So this gives you some valuable information. If you're having a part that's maybe taking a really long time to rebuild, you can go in here and check, is there a specific feature, maybe like a pattern that's causing it? Can I suppress it and then unsuppress it later on once I need it? And then just some additional links we have here. So we do have our own hardware recommendation guides. These do get updated every year. The 2021 one is up right now on our site. We will have a 2022 one soon. We also have the hardware certification listed there, which I know Alex mentioned. So if you're looking for specific systems or hardware, you can go and check to see what SOLIDWORKS has already tested, what they consider to be certified for the software. And then back to that benchmark test. So if you take your results from your RX benchmark, you can actually go compare it with users in the community to see, what your results are compared with everyone else. All right, so that is the end of the presentation here. We do have some time to answer a few questions. I just want to thank you guys all for joining us. And if we don't get to your questions, you can always contact us in the information that you see there.
Awesome. Yeah, I just got a couple minutes left. A couple common questions we're getting. We will be posting our 2022 recommended hardware guides in the upcoming weeks, prior to 2022 SP0 launching later in November, which will include a lot of the information that we're talking about which processors, how much RAM and graphics cards, things like that. And then there was another question, Stephanie, maybe you can answer this. Like, what do you think a large quote unquote assembly is?
I would say not just how many components and parts are in it, but also, how big the file size is, because that's gonna you're gonna need to take that into consideration when opening the file, because a lot of specific features can make an assembly really large. You might just have a few patterns in there, but that can make it now a large assembly. So I guess it really depends, but if you do look at that solution article that I mentioned, there's a lot of good information on, what to do for those large assemblies, and it also talks about, how to efficiently create those assemblies as well.
Right. You're talking about this one, Solid Practices
Yeah.
S076063.
Hmm.
Yeah, I'm gonna leave that up. That PDF was authored by Dassault Systems and their tech support engineering team, and it goes into a lot of best practices about how many mates you should have, talking about flexible mates versus rigid mates, and um, linear patterns, and where those should live, and things
Yeah.
like that. Because all those things matter. You typically have heard like the 10,000 number as a large assembly as a but I've you can make a large assembly with just 500 or 1,000 components if those parts are that complex, like you mentioned, right? So
Yeah.
absolutely.
And there is actually a session in here that's going to talk about large assemblies. So check out the sessions. I know there's one that's going to be done by, I believe, Sean Mars, large assemblies.
Awesome. Awesome. Yep. And all these sessions are recorded. They will be published typically on our website under the webinar section, but they also can be all viewed later on through the Excel platform. I think that it lives for like a week after the session, the conference is over. I've got a couple more coming in here. We've got 50 seconds here. Can we answer one more?
Let's see.
Uh, Man, there's one that's a long topic about virtual desktop. If you can send a message to me somehow directly on here, I can take that offline. That's a pretty big one. 8-core plus processors when SOLIDWORKS barely uses multi-threading. Yeah, I don't think there's a great argument to go greater than eight cores if you're not doing simulation or flow simulation. 8 cores is plenty. Focus on clock speed. Clock speed is king.
And I think the chat might still be open after where we can
Oh, well,
answer
okay, so
questions. I
maybe I'll
believe
send those
so.
messages. Okay, I'll send a message. Hopefully we get that. Anyways, thanks everybody.
Thank you, everyone.